All right, so last video, we're going to do a quick review of vectors. So I have two vectors, vector u, which I've defined by its components, -3, 2. So that means horizontal -3, vertical 2. And I have vector v, which I've defined by its magnitude and its direction angle. Okay, the first thing we're going to do is we're going to get vector u in terms of its magnitude and direction angle. We're going to get vector v in terms of its horizontal and vertical components. We're going to practice going between the two forms for vectors. And then we're going to do all of these things. We're going to find u plus v, we're going to find 3u minus 4v, we're going to find u dot v, and we're going to find the angle between u and v. That's kind of all of the vector stuff that we've done in this class, okay? So first, let's take a vector that's in component form, horizontal and vertical components, and change it over into magnitude and direction angle. So first, just a quick reminder what this means. If I have a vector in horizontal and vertical components, I can think of it as going -3 to the left and 2 up. So that's the end of my vector. So here is vector v. Remember that a vector has direction and magnitude. Okay, now I want to change vector, sorry, this is vector u. I want to change this from horizontal component and vertical component to some magnitude, meaning the length of the vector, and some direction angle theta. So how do we do that? Well, the first thing is the magnitude. The magnitude really is Pythagorean theorem. So I'm going to take the square of the horizontal component plus the square of the vertical component. That's going to equal the square of the magnitude. That's just Pythagorean theorem. Or I can think of the magnitude of u as being equal to the square root of the horizontal component squared plus the vertical component squared. -3 squared is 9. 2 squared is 4. 9 plus 4 is the square root of 13. Okay, so the magnitude of u is equal to the square root of 13. Now to find the direction angle. Okay, well, if we think about the direction angle, right, I know that this distance here, this vertical distance is 2. I know that this horizontal distance here is -3. Think about a trig relationship that involves the opposite over the adjacent. That's tangent. So we can think of the tangent of theta as being equal to 2 over -3, or -2/3. So that means to find theta, I can think about doing inverse tangent of -2/3. And when I do that, okay, calculator. When I do that, inverse tangent of -2/3, we get -33.7 degrees. Now that doesn't make a ton of sense in terms of what is our kind of direction angle, in terms of we want our direction angle to be a positive angle. It starts at x and goes over to here. So how can I change that into something that is a positive angle? Well, let's think about this, right? What is that negative angle giving me? It's giving me this little reference angle here that's going backwards from here to here. So if I take that -33.7 and I add 180 degrees, okay, I get 146.3. So that's going to be, so what did I do? I took this -33.7 plus 180 degrees. Why did I do that? Because I need to get this from, right now it's giving me this angle here, and that's a negative. I want to get this positive because our direction angle is always a positive, okay? When I do that, I get that theta is equal to 146.3 degrees, okay? So I took something that was in horizontal component and vertical component, changed it into magnitude and direction. Now we're going to go the other way. Okay, so now we want to go the other way, okay? So I know that my vector u, which we were originally given in horizontal components, -3, 2, has magnitude square root of 13, and angle measure 146.3. Now we want to go the other direction, okay? So here for v, we're given a magnitude and a direction angle. So let's just sketch what that will look like. Okay, so 300 will get me somewhere over here in quadrant 4. So here's 300 degrees. And what else do I know? I know that the length of that vector is 4. Okay, so how can I change that into a horizontal and vertical component? Well, the answer is to go back to thinking about just basic trigonometry. Okay, So my vertical component would be this piece right here. That's a y. That's this piece here. My horizontal component would be this distance here. Notice that's an x value. That's this guy here. But how do I find those? Well, my vertical component, sorry, horizontal component, this guy here, I can think of using this relationship. Cosine of 300, right? Cosine is adjacent over hypotenuse. So cosine of 300 is equal to x over 4. Solving this for x gives me x equals 4 cosine of 300. So my horizontal component is my magnitude times the cosine of my angle. Okay. Similarly, if we think about our vertical component is going to have to obey sine of 300. Sine is opposite over hypotenuse. Sine of 300 equals y over 4, because notice that our hypotenuse has length 4. That's the magnitude of that vector. Solving this for y gives me y equals 4 sine of 300. So my vertical component is in general going to be the magnitude of my vector times the sine of my direction angle. Okay. Let's go ahead and put those into our calculator, making sure our calculator is in degrees. 4 cosine of 300 is 2. Okay. 4 sine of 300 is negative 3.5. I'm going to go ahead and get decimal approximations in this case. Okay. Let's see if that makes sense. It says that our horizontal component is 2, so we go left to the right 2, and our vertical component is down 3.5. That matches our picture, right? A positive horizontal component and a negative vertical component. That seems pretty reasonable. Okay. So here we practice going from horizontal and vertical components to magnitude and direction angle. Now we just practice going from magnitude and direction angle to horizontal and vertical components. Okay. Now let's use that information to answer these 4 questions. Okay, so I'm going to erase. All right, so now let's answer these questions. First, we want to find u plus v. Well, to find u plus v, do we want to use our horizontal and vertical components, or do we want to use our magnitude and direction? It's going to be a lot easier to do this algebraically, meaning I want to think about u as negative 3, 2, and v as 2, negative 3.5. Now, when we add vectors or subtract vectors, we add or subtract component-wise. So that means negative 3 plus 2 is going to give me my new horizontal component. Negative 3 plus 2 is negative 1. And 2 minus 3.5 is going to give me my new vertical component. 2 plus negative 3.5 is negative 1.5. Okay. So in component form, u plus v is negative 1, negative 1.5. Okay. Next, we're asked to find 3u minus 4v. Again, this is going to be easier to do if we do it in component form. Okay. So I want 3 times my u, negative 3, 2, minus 4 times my v, 2, negative 3.5. Okay. So these 3 times u and 4 times v represent scalar multiplication. The nice thing about scalar multiplication is you can just distribute. So 3 times negative 3 is negative 9. 3 times 2 is 6. Minus 4 times 2 is 8. 4 times negative 3.5 is negative 14. I'm pretty sure that's right. Now, when we subtract, we can think of adding a negative, or really we can just subtract component-wise. Okay, so what do I mean by that? Negative 9 minus 8. Negative 9 minus 8 is negative 17. 6 minus negative 14 is 6 plus 14, which is 8, I think. Okay. So 3u minus 4v is negative 17, 8. Okay. All right, let's move on and find the dot product. Okay. There are 2 ways that we can find the dot product. We can find the dot product algebraically, and we can also find the dot product geometrically. Okay, so I'm going to go ahead and erase our first two questions so that we have room to work. The dot product algebraically, right? So if I think about u dotted with v, means I'm going to multiply horizontal components and then add that to the multiplication of the vertical components. Okay, so if I want to do -3, 2, that's my u, dotted with 2, -3.5. Again, what I'm going to do is I'm going to multiply my horizontal components. -3 times 2 is -6. And I'm going to add that to the multiplication of my vertical components. 2 times -3.5 is -7. -6 plus -7 is -13. So u dotted with v is -13. Remember, the dot product takes two vectors and spits out a scalar, something that's not a vector. Okay? All right. So the last thing we're going to do is we're going to find the angle between u and v. Okay? Now, there are two ways to do this. One, I could try and sketch a picture of this and do some subtraction and try and figure out what, where to go from there. Or we can use the other interpretation of the dot product. Okay? What do I mean by that? Well, I also know that u dot v is equal to the magnitude of u times the magnitude of v times cosine of the angle between them. So this theta is the angle between the vectors. But isn't that exactly what I want to find? The angle between u and v? So as long as I know all of the other values in this problem, I can solve that for cosine of theta. Well, which means I can solve that for theta. Okay? So here's what we can do. Didn't we just calculate u dot v? We know that u dot v is -13. Okay? Do I know the magnitude of u? Yep, the magnitude of u is the square root of 13. We calculated that up here. Do I know the magnitude of v? Yep, the magnitude of v is 4. Okay, so now I'm going to solve this for cosine of theta by dividing both sides by the square root of 13 and 4. Okay. So that gives me that cosine of theta is equal to -13 divided by square root of 13 times 4. Okay, now that's not pretty. Well, I don't care. Because what am I going to do? I'm going to take an inverse cosine to get theta is equal to the inverse cosine of -13 over square root of 13 times 4. Yuck, but that's why we have calculators. Okay, so I'm going to do inverse cosine of -13 divided by the square root of 13 times 4. All that, the square root of 13 times 4 is all in the denominator, so maybe use like some extra parentheses. And I get 154.3. So I get that theta equals 154.3 degrees approximately with some rounding. Okay? Okay, now what I want to do is I want to see if that really makes sense based on kind of the work that we did up here. So I just want to do a quick sketch and make sure that our answer here makes sense. Okay, so let's give ourselves a nice set of axes here. And I'm going to sketch both of these vectors. Okay, so first of all, I'm going to sketch u. We know that u is at 146.3 degrees. Okay, so that's less than 180, so u is somewhere over here. Okay, and this angle here is 146.3 degrees. Okay. What else do we know? We also know that vector v is somewhere down here. Okay, so here's vector v, and this angle is 300 degrees. Okay. All right, now what we want to know is we want to know the angle between them. Okay? In other words, we kind of want to know this angle right in here, the angle between these two. So how can I find that? Well, one way that I can find the angle between them, right, is I can take this whole angle, which is, wow, That should not have started there, right? Should have started here, about 300, sorry. I can take this whole purple angle, 300, and subtract that theta, that 146.3. Let's look at what happens when I do that. When I do 300 minus 146.3, what do I get? I get 153.7. 153.7 is pretty close to 154.3, considering that we had to do a fair amount of rounding, okay? So that definitely matches with kind of our picture of what we would get here. So one way we can find the angle between two vectors is to use this interpretation of the dot product. Fill in u dot v algebraically, fill in the magnitude of u, fill in the magnitude of v, then the only thing we won't know is this cosine of theta term, and we can solve for theta.